Okay, we're going to start rational functions. Rational functions, the big thing here are asymptotes and wholes that appear later. Rational functions look like big, hairy fractions to me. They are a polynomial over a polynomial. Sometimes it's just a constant over a polynomial. Sometimes they're in factored form like this one. Sometimes they're not. What we're looking at here is asymptotes, these invisible lines that go between the two sides of the graph. Sometimes they lie underneath the graph. Sometimes they're just in between the graph. So we're going to go over steps to figure out how to find vertical and horizontal asymptotes. First, you find your vertical asymptotes by setting your denominator equal to 0 and solving. Your horizontal asymptote, there are three cases it could fall in. Now your N and your M, look at this carefully. It's determined the degrees of your N and your D. Your degree of the numerator, that's your N, and the degree of your denominator, that's your M. So if the degree on top is less than the degree on bottom, then the graph has a horizontal asymptote at y equals 0. So, for example, this could be x over x squared plus 4. Horizontal asymptote is going to be at y equals 0. If the degrees are the same, say x over x plus 2, both of these are of degree 1, I'm going to look at my leading coefficients. I've got a 1 over a 1. So this one, y would be 1. If I look at one that's 2x minus 4 over 3x plus 2, I'm looking at y equals 2 over 3. If the top has a higher degree than the bottom, there are no horizontal asymptotes. So x cubed minus 3 over x plus 2 would not have a horizontal asymptote. It is top heavy. Finding these asymptotes, we're going to first look at our vertical asymptotes. I'm going to take my denominator, x squared minus 1, set it equal to 0 and solve it. So x equals plus or minus the square root of 1, which is plus or minus 1, which means I have vertical asymptotes at x equals plus or minus 1. So there's my vertical asymptote. Horizontal asymptote. I've got a degree on top of 2, degree on bottom of 2. Since they're the same, I look at my leading coefficients, 5 over 1, so y equals 5 is my horizontal asymptote. That means on my graph, at x equals plus or minus 1, I've got vertical dotted lines to go in there, and at y equals 5, I'm going to have a horizontal. Okay, start with vertical asymptotes. Take your denominator, 3x squared plus 1, set it equal to 0. 3x squared equals negative 1, x squared equals negative 1/3. And x equals plus or minus the square root of negative 1/3, which means there is no vertical asymptote. Why? Because taking the square root of a negative is an imaginary number. Now if I look at my horizontal asymptotes, then I'm looking at my degrees. Degree of 1 on top, degree of 2 on bottom, which means I have a horizontal asymptote of y equals 0 when the top is less than the bottom. You find holes in the graph when you have common factors between your numerator and denominator. So right here we're going to find asymptotes and holes. First I need this into factored form so I can figure out if it does have any common factors. X minus 1, x plus 2, On the bottom, let's see, it's got to be x and x multiplies to negative 6, adds to negative 1, negative 3, positive 2. I can see there's going to be a hole right here. X plus 2 equals 0 means x equals negative 2 is a whole. I take those out. Those no longer mean anything. When I look at my vertical asymptotes, looking for vertical asymptotes, I take what I have left on the bottom, which is x minus 3 equals 0. So x equals 3 is a vertical asymptote. Horizontal asymptotes, look at your degrees from the original. Okay, degree on top is 2. Degree on bottom is 2. Look at your leading coefficients. Y equals 1 over 1. So y equals 1 is a horizontal asymptote. Okay, one more time. Try it yourself. See if you got the right idea. First thing I'm going to do is factor. See if there's any holes in this. X and x multiplies to 9, adds to 6 would be plus 3 and plus 3. X and x multiplies to 3, adds to 4 would be 3 and 1. Right here, got a hole. Hole at x equals negative 3. Vertical asymptotes, take what's left on the bottom, set it equal to 0. X equals negative 1 is a vertical asymptote. Hole at x equals negative 3. Vertical asymptote, x equals negative 1. Horizontal asymptote, look at your degrees. Degree on top is 2. Degree on bottom is 2. Y equals 1 over 1. So y equals 1 is my horizontal asymptote. Okay, we're going to add domain in there, which is basically everything except for your holes and your vertical asymptotes. So let's solve this like we normally would. This is not written correctly. Let me fix that. Okay, here's the correct problem. I do not have any factoring techniques for factoring a cube with 3 terms or a cube with 2 terms. That's not a sum of perfect cubes. 3 is not a perfect cube. So we're going to say there are no holes in this graph. We do need to find our vertical asymptotes by setting my denominator equal to 0. Negative 3x cubed equals negative 1. X cubed equals positive 1/3. X equals, how do you get rid of a square? You square root. So when you get rid of a cube, you cube root 1/3. So I've got vertical asymptotes here. My horizontal asymptotes, and take my degree on top equals 3. Degree on bottom equals 3. I want to look at my leading coefficients, 2 over negative 3. There's my horizontal asymptote. My domain, left and right, this is where sketching a graph does come in a little handy. Vertical asymptote at radical, or cube root of 1/3, which is going to be somewhere, oh, it's positive, so let's undo that. Okay, so I'm going to have a vertical asymptote somewhere in the positive realm. I've got a horizontal asymptote somewhere in the negative realm. My domain is when I'm looking left and right. My graph can come in from negative infinity, do anything it wants until it gets here, and it's got a break. And then it can pick up, go all the way to positive infinity. So my domain is all real numbers except where I had that asymptote, except at x equals cube root 1/3. Domain.